Alrighty, so we are going to talk about the Nikola Tesla 369 key to the universe mathematical derivation, where it actually comes from, and so let's just get right into it. People have decided to take the number 1 and then double it, because apparently that's how cell division works. I don't really know why that has anything to do with math. But we double these numbers, and then we're going to digit sum them. And then we get these numbers. And this is our repeating sequence right here. And people have decided to say that, 1, 2, 4, 8, 7, 5, well, 3, 6, and 9, those aren't in this sequence. Those must be like independent from the universe and control all things and all this shenanigans. And the biggest conflict with that idea is, first, you can't just manipulate patterns in math and then draw these huge conclusions about them. That's just not how science works. Yeah, there's not much more to say about that. And the second thing is this pattern right here, this sequence of numbers doubling and then looking for this repeating sequence and then looking for the numbers that aren't in that repeating sequence, that only applies to base 10. And it's important that you know how bases work before we, I guess, go on in this video. I'll put a link in the description of an explanation just for how bases work. I'll give like a brief overview, but if you want a better grasp, you should watch that video. But base 10 is the number system that we're all fine and dandy with and we're familiar with. So this is 0 through 9. So base 10, we have 10 symbols that represent numbers that we can play around with. That's what base 10 means. Base 2, right? We only have 2 symbols that we're allowed to play around with. And just to like ensure that you understand how bases work, base 11 means that we have 11 symbols to play around with. So that means that we have our normal 0 through 9, but we run out of the numbers that we're familiar with, so we decide to call the 11th symbol A, right? So these can be a little tricky because for most people, base 10 is the only number system that you'll interact with, and it's been like that for centuries, really. Well, however, I don't know the history of math, but people think that the decimal system, base 10, is such a prominent one because we have 10 fingers, and when people were kind of figuring out how to interact with numbers, it was pretty intuitive to use your 10 fingers for base 10. But anyways, this isn't a history lesson. This is where 369 actually comes from. So this pattern right here, I repeated it for all of the bases. Base 2, and then I went all the way up to base 11 just to make sure that it applied above base 10, this pattern that I found. But let's just look at base 2 first. And so again, we have these numbers, and we're going to double them each time we go to the right. And if you're in your head, if you're saying, wait, you're multiplying them by 10, you're not doubling them, this is doubling these numbers in base 2. So if that confuses you, make sure you watch those videos and you understand how bases work, because this is doubling right here. And then we're going to digit sum these numbers. So 1 plus 0 is 1, 1 plus 0 plus 0 is 1. You get the idea, we get 1 repeating. So I put this purple bracket around the repeating sequence that we get for each of these bases, right? So again, we're going to do the same thing for base 3. We're going to double every time we go to the right. And these numbers in green, I already did this video, but my microphone wasn't on, so that's why there's some annotations here and there. But base 3, we are allowed to use 1, 2, 3 numbers. Okay, that was a little confusing. 0, 1, and 2, that's 1, 2, 3 numbers. That's why we call it base 3. There's 3 symbols that we're allowed to use. Probably could have explained that better. I hope I didn't confuse you. Anyways, so we have this, we double them and we digit sum them. And it's important that we digit sum these in base 3. So 2 plus 2, yeah, we know it's 4, but when you digit sum in base 3, you get 2. Anyways, so what I've done with this navy blue right here is this is the number, or eventually it'll get to plural, but in base 3, so we have 0, 1, 2. This is the number that is not involved in this repeating sequence right here. Okay, so just remember that. We ignore 0. I'll get to why we ignore 0 later also. But for right now, just these numbers that are in these boxes, just remember that they are not involved in the digit sum right here. This repeating sequence. So you'll see that pattern again right here in base 4. So we double each time. And I guess I accidentally erased it when I was erasing it from the previous time I recorded this damn video. But we're doubling each time, we're digit summing, and we get this digit sum right here, and that's 3. And in this repeating sequence right here, out of these numbers, not including 0, I'll get to that later. So we're using 1, we're using 2, we're not using 3 in this repeating sequence. So I'm going to put this 3 in this box right here. All right. Moving on. Base 5, you get the idea. Base 6, things are a little tricky because originally when I was figuring this out, I was just adding these numbers together. In this case, in base 6, I was doing addition of these numbers in base 6. And obviously that is larger than 5. So that was confusing to me, and just on a whim, I decided instead of adding to digit sum these numbers, and when you digit sum these numbers in base 6, you get 5, right? So let's talk about these numbers right here. Okay. So you will notice that this repeating sequence right here, sorry, I didn't annotate, this repeating sequence right here, when you digit sum it, which in this case it's just one number, so there's not much math to do, it's 1 less than the base that you are in. So we're in base 2, that number that we get down here is 1 less than the base that we're in. Again, that applies to base 3, because that's 2. That applies to base 4, because this number is 3. And base 5, another simple one. But base 6, that's where things kind of tripped me up, because I was so used to this pattern of this number being 1 less than the base that we're in, and then I just decided to digit sum. So then, thankfully, this pattern still held true. But yeah, this number is significant only because it's always 1 less than the base that we are in, right? And we get this number by digit summing the repeating sequence, okay? So that is the pattern. That is the significance of this repeating sequence right here. When you digit sum this repeating sequence, you get you get a number. I kind of stumbled with my words. You get a number that is 1 less than the base that you are in, right? So that's kind of what's going on. And again, in this navy blue, this number is the only number in this number system right here. So we're not including 6, 7, 8 because those numbers, they don't belong to base 6, right? So 5 is the only number that isn't involved in this repeating sequence right here. 1, 1, 2, 3, 4, but not 5. So that's why 5 is in this navy box right here, okay? So I think you get the idea. The same exact pattern holds true for base 7, base 8, base 9. Again, when you digit sum this repeating sequence, you get a number that is 1 less than the base that you are in. And again, in this navy box right here, I have sectioned off the numbers that are not involved in this repeating sequence, right? So we're tackling this in a very repetitive way, right? Because the whole point of this is that we're analyzing all these bases, right? Because again, humanity has just decided to use base 10. We can do physics, we can do chemistry, all math applies and behaves as it should in other bases. We just decide to do it in base 10. So the fact that we're drawing a conclusion from base 10, it doesn't hold any significance at all. Anyways, so now we're going to talk about base 10. Now we're going to talk about the patterns that I've been describing in these other bases, and hopefully you'll see it all click and come full circle when we look at it in base 10, this time from a new perspective. So base 10, we have 10 symbols that we're allowed to play with. Again, we double every time we go to the right. And then we're going to digit sum these numbers, and we get these single digit numbers. And so this is our repeating sequence, right? Xia. And again, we're going to digit sum it, because that's the pattern that we've been doing across these other patterns. So we'll do 3 plus 4 plus 8 plus 7 plus 5. So this is 7 right here, that's 7. So we'll add those. 14 plus 8 plus 5, 22 plus 5, 27. And then again, we have a 2-digit number, so we got to make that a 1-digit number with some more digit sum shenanigans, and we get 9. So that's where this guy comes from. Well, why did that draw? This guy. And wouldn't you know, this 9 is 1 less than the base that we're in. So again, this pattern is prominent. And just like the other bases, this box right here, these are the numbers that are not involved in this repeating sequence. And the only significance of this repeating sequence is when you digit sum it, you get the number that is 1 less than the base that you're in. That is consistent across all of these bases. That is a true pattern, a true quote-unquote meaning. It's much more meaningful than just deciding to claim that you can make infinite energy and completely solve the periodic table and all these bizarre claims that 369 claims to be the key to. So yeah, one more time. I'll just say it one more time to really define it. So 369 right here. These are the numbers that are not involved in this repeating sequence right here. In this repeating sequence, when you digit sum it, you get the base, you get a number that is 1 less than the base that you are in. And I mean, for all I know, it's a really cool pattern. I really don't feel like looking into it really far and like figuring out why mathematically this pattern holds true for all these bases. I mean, it's really cool. Sometimes it's as simple as just an 8 repeating over and over and over again. And then we have some more complicated ones like base 6. Interestingly enough, this pattern still applies to base 11. So when we do these doublings as usual, and then we look at the repeating sequence that we get, When we digit sum this repeating sequence, we get one less than the base that we are in. So we get, if this is confusing to you, then you need to brush up on bases some more. But this number, this needs to be single digit, and this number is quote unquote 10. But we don't have a symbol for 10 in our number system. It only goes up to 9, right? That doesn't really look like a 9. It only goes up to 9. So just like right here, it only goes up to 9. So our 10th, well, why did I just write that? Not 110. Our 10th number is A, right? So our 10th right here is 1 less than 11 up here. So this pattern still holds true. Yeah. So I hope that this gave you a different perspective on the 369 answer to the universe shenanigans. It's important that when you watch videos on YouTube, there should be a very thorough explanation with a lot of background and things that you can think for yourself and understand. Surely don't just watch videos of random people on the internet and they just manipulate patterns with math and say, oh, wow, these numbers are not involved in this sequence. They're the key to the universe. Like, you need to ask yourself why multiple times when you are absorbing new information. Because if you're just spoon-fed something that, like, this person has no idea what they're talking about, and you believe it, yeah, that's a very, very big issue, I guess. I'll quit rambling about my distaste for the ignorance of science. I wanted to show this pattern that I found to the public and hopefully educate some people. Yeah. All right.